Climate extremes, intense heat waves, floods, droughts, are occurring more frequently and more intensely than in the past. They are happening more often, lasting longer, and affecting millions of people, including here in Germany. But how can scientists prove climate change is real? How can we measure it over time? Just like DNA sequencing helps fight pandemics or MRI scans help doctors locate tumors, systematic data lets scientists understand climate. One of the most important of these systems is a data set called Global Historical Climatology Network, DAILY, GHCN-D, a global record of daily weather observations from thousands of stations around the world.
Now that we understand why climate data matters, let's look closely at what the GHCN-Daily Dataset actually contains. GHCN-Daily is not a single file. It is a massive collection of station-level CSV files, each representing one physical weather station on Earth. In total, the dataset contains over 129,000 station CSV files, covering 219 countries, with observations stretching from the 18th century to today. Each file answers one simple question: what did this specific weather station measure day by day? Let's zoom in to one example file, a file named ACW000-11604.CSV. corresponds to one unique station ID. That station has a fixed geographic location, elevation, and metadata. Inside this file, each row represents one calendar day. So conceptually, the structure is one file, one station, one row, one day, one column, one measured climate element. This design makes the dataset extremely scalable and transparent. Each station records one or more meteorological elements. The 5 core elements you will see most often are Tmax, daily maximum temperature; Tmin, daily minimum temperature; PRCP, total daily precipitation; snow, daily snowfall; SNWD, snow depth. Temperatures are stored as tenths of degrees Celsius, and precipitation is stored in millimeters. Beyond these, the dataset includes over 40 additional elements: wind, evaporation, soil temperature, cloud cover, weather events, and more. In total, across all stations, more than 1.14 billion station day records are present in the dataset. This makes GHCN-Daily the largest daily land-based climate archive in the world. When we look at the full temporal span of the data, the earliest observations go back to 1763, and the most recent records extend into late 2025. That is over 96,000 days of climate history. For Germany alone, 1,123 weather stations are present. Over 70 years of dense, modern coverage. Enough data to study both long-term trends and extreme events. Before trusting a dataset of this size, we must ask whether it follows the FAIR principles. Findable. The dataset is publicly hosted by NOAA with clear documentation and station metadata. Accessible. No accounts, no paywalls. The data is downloadable as plain CSV files. Interoperable. Each file uses standard formats, consistent column names, and machine-readable metadata. reusable. Quality flags, source flags, and detailed documentation are provided, allowing researchers to reproduce results and audit assumptions. These properties are what make GHCN-Daily suitable for scientific, educational, and policy use. GHCN-Daily has several major strengths. It is global in coverage, daily in resolution, long in historical depth, openly available. But it also has limitations. Station density is uneven across the globe. Older stations may have instrument changes or relocations. Urban stations can be influenced by heat island effects. These are not flaws to ignore. They are factors to account for during analysis. Responsible climate analysis always acknowledges these constraints. First, we created a monthly temperature spiral for Germany. This chart places time on a circle. January through December form one loop, and each year expands outward. Early decades sit near the center. Recent decades push outward. What we see is not random wobbling. The spiral steadily grows. That means German summers are getting hotter and German winters are getting milder. Seasonal variation is still there, but the entire climate is shifting upward. Next, we computed the global mean temperature from 1900 to today. Every point on this curve represents the average of thousands of weather stations across every continent. The shape of the curve is unmistakable. Small year-to-year fluctuations, but a strong upward trend across more than a century. This is the fingerprint of global warming. Not spikes, but persistent increase. We then repeated the same calculation, but using only German stations. When we place Germany's curve next to the global curve, they track each other closely. Some years Germany warms faster, some years slightly slower, but the direction is the same. This tells us something crucial. Germany is not an outlier. It is part of a global physical process. Initially, we compared temperature distributions between two periods, not just averages, but the entire shape of daily temperatures. For 1951 to 1980, most days cluster around 8 degrees Celsius. For 1995 to 2024, that entire bell curve has shifted right, toward 10 degrees Celsius. This is the most powerful signal in climate data. Not just higher extremes, but a new normal. Cold days are less common. Warm days are more common. Everyday life now happens on a warmer planet. All of these signals, spirals, trends, distributions, extremes, and nighttime warming, come from the same source: daily station measurements. No simulations, no assumptions, just one planet measured one day at a time. Now we focus on Germany's yearly average temperature from 1950 onward. Each point is a full year of daily readings, aggregated across hundreds of stations. The orange line still wiggles. That's normal weather variability, but the baseline is clearly rising. The orange curve is a robust national average designed to reduce outlier stations and missing data effects. The dashed line is the long-term linear trend, about 0.27 degrees Celsius per decade, and the black line is the 10-year rolling average showing the climate signal, a steady climb, especially after the 1980s and into the 2000s.
Now, let's look at the yearly maximum temperature, the hottest daily TMAX observed anywhere in Germany each year. This series is naturally spikier because extremes depend on a few heat wave days. But the direction is still clear. The dashed trend rises at about 0.46 degrees Celsius per decade. And the 5-year rolling line shows the ceiling lifting, meaning the most extreme hot days are becoming more frequent and more intense in recent decades.
This analysis is only a starting point. With GHCN-Daily, we can study heatwave duration and frequency, analyze extreme rainfall events, train predictive models for climate risk, validate regional climate simulations, support evidence-based infrastructure and policy planning. The dataset does not tell stories on its own, but when analyzed carefully, it provides one of the clearest empirical records of how Earth's climate is changing.
GHCN-Daily is not just data. It is measured history, recorded one day at a time across the entire planet. And that history is essential for understanding our future.